Day 4, Problem 1. A fire hydrant is 2.5 feet high and casts a 5-foot shadow. At the same time, a nearby tree casts a 17-foot shadow. A, sketch a diagram, and then B, use similar triangles and a proportion to compute the tree's height. Okay. So, part A, sketch a diagram of this. Well, let's say this is the ground, and there is a fire hydrant. So here might be a fire hydrant, just a little rectangle thing, the fire hydrant. Now it says nearby there is a tree, and so the tree is taller than the fire hydrant probably, and so I want to draw a tree. And so this might be our tree. Now, the tree and the fire hydrant are casting a shadow on the ground. That means that the sun has to be out. And so, one possible position of the sun might be, let's see, way high up in the sky, but to get it to fit on the piece of paper, let's say that this is the sun right here, right? And here's the rays of the sun. Okay. Now, how shadows are created is as a sun ray comes down and clips the top of any object, or as it continues down and clips the top of the fire hydrant, it will eventually strike the ground. And all of this, right, is bright from the sun. This is all bright here, but this spot right here on top of the ground is going to be dark because this fire hydrant is blocking the rays of the sun. They're hitting the fire hydrant and being blocked, and that's going to create a darker spot on the ground, and that's what a shadow is. Now the same will be true of the tree. The tree is blocking the rays of the sun from passing through and making the area right here bright, and so that creates a dark shadow along the ground for the tree. Okay. Now here is our diagram of the problem, but we can do even better than this because we have some measurements in the problem and we can do some labeling. So it tells us that the fire hydrant is 2.5 feet high, and so this distance here is 2.5 feet, and it casts a 5-foot shadow. So the distance from here to the fire hydrant is 5 feet. And the tree casts a 17-foot shadow. So from the base of the tree all the way to this spot right here, that entire distance all the way across there is 17 feet. Now, what we do not know, and we're asked to figure out, is how tall is the tree. So this distance here, we do not know that, and we could pick a variable to represent that. I'm going to use the letter X to represent the height of the tree. Now, I notice there are some shapes here that in math class we recognize as triangles, and specifically as right triangles. Focusing at the location where the fire hydrant is, I see a small right triangle. There's a 90-degree angle in this corner of the triangle, and the height of the triangle is 2.5, and its base across here is 5. Okay. There is another triangle that is similar in shape. One side of it is this here, and then the diagonal side all the way down, and then right all the way across the bottom. So here is a triangle the same shape as the small triangle, is just larger. These are similar triangles, and that is what part B is getting at when it refers to using similar triangles to be able to use relationships that we observe about a fire hydrant and its shadow to help us figure out an unknown height based on its shadow. So let's tackle part B. Use a proportion to compute the tree's height. Okay. Now, what a proportion is a particular kind of equation where the expression to the left side of the equals is a fraction, and the expression to the right side of the equals is a fraction as well. So some number compared to some other number will be equal to a number compared to a number. Now let's look at our information regarding the fire hydrant and its shadow. We know that the fire hydrant is 2.5 feet tall. I can use that as the numerator of my first fraction and compare that to its shadow, which is 5 feet long. I'm going to use the 5 as the denominator of that fraction. So again, the height of the fire hydrant, the shadow of the fire hydrant. On top of my fraction, I have a height. On the bottom of my fraction, I have the length of a shadow. Let's follow that same order when we make our other fraction that is going to relate to the tree. Again, on top of the fraction, height, the bottom of the fraction, the shadow. Okay, so the height of the tree, we do not know the height of the tree. That is the side that has an x on it. So the variable x goes here. And now the shadow for the tree. That is this side of the triangle, which is 17. And so 17 is the denominator of that fraction. And this equation is called a proportion. And that is what we were asked to use in Part B, a proportion to find the tree's height. So we would like to solve this equation for the variable x. We want to get the variable x alone. So here's the equal symbol. I'm going to draw a vertical line downwards to keep the left side separate from the right side and solve for x. Okay. Here is the variable x. And right now, near the x, there is a divide 17. And we can remove divide 17 by multiplying by 17. So on the right side of the equation, I'm going to multiply by 17. And the same on the left side of the equation. Multiply by 17. Now, figuring out what happens when we do that. X times 17 makes 17x. And it still has a denominator of 17. But 17 divided by 17 is 1. And so this is going to reduce to 1x. And 1x is just x. So the reason earlier that I had multiplied by 17 essentially is because if a fraction has a denominator of 17, multiplying by 17 has the effect of canceling away that denominator, leaving the numerator, and that's how I'm able to get the letter x alone. Now, on the left side of the equation, let's multiply the 17 times this fraction and see what we get. Okay. I'm going to grab a piece of scrap paper, and we need to figure out what 17 times 2.5 over 5 makes. So 17 times 2.5 over 5. What does that make? Let's see. So the whole number 17 could be rewritten as 17 over 1. It just helps to keep the numerators straight and the denominators straight. And across the top now, 17 times 2.5. So 17 times 2.5. 7 times 5 is 35. Write the 5 and carry the 3. 1 times 5 is 5, plus 3 is 8. Start the next row with a 0. 2 times 7 is 14. Carry the 1. 2 times 1 is 2, plus 1 is 3. Add together these rows. 5 and 0 is 5. 8 and 4 is 12. Carry the 1, and that is 4. The problem has one number to the right of the decimal, and so if we put the decimal point here, there will be one number to the right of the decimal in the answer. That is 42.5. So when multiplying these together, 17 times 2.5 makes 42.5. In the denominator, multiplying together 1 times 5, that is 5. And so we have 42.5 over 5 let's figure out what that makes. 42.5 divided by 5. Okay. So 5 divides into 42.5. 5 does not divide into 4, so instead of using 4, let's use these numbers together as 42. 5 divides into 42 8 times. 8 times 5 is 40. Subtracting, 2 subtract 0 is 2. This decimal point goes straight up above, and the 5 can be brought down below. Now 5 divides into 25 5 times, and 5 times 5 is 25. There is a remainder of 0. So this division, 42.5 divided by 5, works out to be 8.5. Back to the warm-up. When we had worked this part out, we figured out 8.5. Okay, so we have x is equal to 8.5. And in our original drawing, the variable x, this side of the large red triangle, is the height of the tree. And so the height of the tree is 8.5 feet. Now day 4, problem 2. A cylinder has radius 8 millimeters and height 3.5 millimeters. Sketch a picture. Okay, so a picture of a cylinder. An oval is the top, and now the sides, and then make the bottom curved. That gives it the illusion that it goes around. Now we are told that the radius of the cylinder is 8 millimeters. The radius of a cylinder is the distance from the center of one of those circles to the edge of the cylinder. And so that distance is 8 millimeters. And we're told that the height is 3.5 millimeters. So from the top circle to the bottom circle of the cylinder is 3.5 millimeters. There is our picture. Now part B. Use the formula S equals 2 pi RH plus 2 pi r squared to find its surface area. So we are asked to find the area of all surfaces of this three-dimensional object. Now the cylinder will have a top surface, which in reality is a circle. It will have a matching bottom surface to it, which is a circle. And it also has the part of the cylinder that wraps around, right? All this part right here that wraps around the three-dimensional object. And we're told that this math formula can be used to find that total surface area for the cylinder. And so to do this, I'm going to write that formula, S equals 2 pi RH plus 2 pi r squared, and then substitute values from our drawing in place of these symbols. And so we have S equals 2. Now pi can be filled in with 3.14. The letter R is the radius. That is 8 millimeters. And the letter H is the height of the cylinder. That is 3.5. And then plus 2 parentheses. The pi again is 3.14. And the letter R again is 8. And so to find the solution for S, which means surface area, it looks like we need to multiply quite a few numbers together, and then here there's an add involved, and then here we're back to multiplying a bunch of numbers together. So let's do that. Okay. Now this first piece, 2 times 3.14, that makes 6.28. And we can then multiply the 6.28 by 8. So let me grab a piece of scrap paper and we can figure out what that makes. So 6.28 times 8. 8 times 8 is 64, carry the 6. 2 times 8 is 16, and 6 is 22, carry the 2. 6 times 8 is 48, plus 2 is 50. And the decimal point needs to go right here, 50.24. Next comes multiplying by 3.5. So on the scrap paper, our 50.24, we multiply by 3.5. 4 times 5 is 20, carry the 2. 2 times 5 is 10, plus 2 is 12, carry the 1. 0 times 5 is 0, plus 1 is 1, and 5 times 5 is 25. Start the next row with 0. 3 times 4 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. 3 times 0 is 0, and 3 times 5 is 15. And then add these results together. This is 0, 4, 8, 5, 7, and the 1. There are 1, 2, 3 digits to the right of the decimal in the problem. And so in our answer, if we put the dot here, there will be 3 digits to the right of that dot. And that result is 175.84. Okay. So this first part, when all multiplied together, makes 175.84. Okay, now we have to add this expression. So let's do a little bit of work on this. Again, 2 times 3.14 makes 6.28, and 8 squared is 64. So on our scrap paper, let's figure out 6.28 times 64. So 6.28 times 64. 8 times 4 is 32, carry the 3. 2 times 4 is 8, plus 3 is 11, carry the 1. 6 times 4 is 24, and 1 is 25. Start the next row with a 0. 6 times 8 is 48, carry the 4. 6 times 2 is 12, plus 4 is 16, carry the 1. 6 times 6 is 36, plus 1 is 37. And then add these results together. That's 2, 9, 11, carry the 1. 3 and 7 is 10, carry the 1. And 3 and 1 is 4. There are 1, 2 digits to the right of the decimal point, and so in the answer we'll put the decimal point here so that there are 2 digits to the right of that decimal point. That is 401.92. Okay, back to the warm-up. This expression was 401.92. The final thing to do to get that surface area is to add this number and this number together. And so 175.84 add 401.92. Let's see what we get for our surface area. 4 plus 2 is 6. 8 plus 9 is 17. Carry the 1. These dots line straight up. Here's the dot. 5 plus 1 is 6. Plus the 1 is 7. 7 plus 0 is 7. And 1 and 4 is 5. So our answer for S is 577.76. The variable S is representing surface area, and so we have figured out that the surface area of this cylinder is 577.76 square millimeters.